Hello, I'm Dr. Michelle Waddell, and I'm an assistant professor, Department of Chemistry and Biochemistry at Hampton University. And I'm the moderator for today's talk, which is on conducting engaging chemistry laboratory classes from freshman to senior level in a remote environment. Our presenters will be Dr. Kesete Ghebreyessus, Dr. Peter Njoki, and Dr. Edmund Ndip. And before I get started, some housekeeping things. There will be a survey for today's talk in the chat, so please fill that out. Also, the next collaborative talk will be on February 3rd, given by Auburn University. Let me go ahead and start the slideshow here. So this is the outline of the talk today. I'm going to give you a little introduction and background about Hampton University. And then each one of us are going to talk about different labs. I will start it off with talking about the organic chemistry labs. Dr. Ghebreyessus is going to talk about general and inorganic chemistry labs. Dr. Njoki will talk about introduction to chemistry labs for non-science majors. Dr. Edmund Ndip will talk about physical chemistry. And then at the end, we will have 3 undergraduates who are on now who will talk about the experience from their end. And we will have a Q&A at the end. So if you have any questions that you want to give us, but you're afraid you might forget, you can go ahead and put that in the chat feature. So Hampton University is a historical Black university, college and university, founded in 1868. And we are in Hampton, Virginia, which is in the southeastern corner of Virginia. We are surrounded on 3 sides by water. So that's what our saying is, home by the sea. We are the number 4 ranked HBCU by World News, by US News and World Reports. We have the doctoral programs in business, counseling, physical therapy, physics, pharmacy, nursing, and planetary and atmospheric sciences. We also offer Master of Sciences in all the sciences, education, and business. We are also classified as a Carnegie Commission High Research Activity Institution. We are one of the 6 institutions that are part of the NOBCChE Collaborative, which are made up of 3 historically Black colleges and universities and 3 predominantly white institutions. And those institutions are Hampton University, Winston-Salem State University, Jackson State University, the University of Pittsburgh, the Ohio State University, and Auburn University. We joined the collaborative, came together in 2015, and the first collaborative meeting was at Winston-Salem State University in 2018. Hampton University was supposed to sponsor the spring 2020 collaborative meeting, but as we all know, COVID came down, and we are living through COVID as we speak. So we are dealing with that, and that's what this talk is all about. So before COVID, actually, we had a meeting in the Department of Chemistry to reorganize how we did our organic chemistry laboratories. So prior to that meeting, all students who wanted to take organic chemistry, whether they were majors or non-majors, took the same course, lecture, and lab. So it was decided to separate them. So the one section, what we call the honors section, will be biochemistry, chemistry, chemical engineering, and honors students. And we wanted them to do more guided inquiry, more challenging, more in-depth topic. And then the other course, which was for the pre-medical health section, that was for the biology, the marine science, pre-pharmacy, and the pre-health majors. And that course, we want to bring more biological aspects in, more medical aspects to it. So that was designed in the spring of 2020. Then, as I said before, COVID hit, and we had to decide, okay, how are we going to do these labs online, and how are we going to make it user-friendly to our students? So that summer, there were lots of webinars going on, And actually, the American Chemical Society did webinars on doing online labs. And so I got some ideas from that. And one of those was from North Carolina State University. And they did what we call a virtual lab. And they said that you can use this for free if it helps you for your online experience. So we decided to do a combination of Jove, science education, and lab manual videos, which Hampton University got a subscription for, and the North Carolina State University virtual reality organic chemistry lab experience. And part of that design, we wanted to make it engaging students so they weren't just watching videos all day long. So we had them write journal entries, which basically they watched the videos on how the experiment was done, but instead of doing a traditional lab report, organic chemistry can be from 4 to 8 pages long. We wanted to make it something more concise because they weren't doing experiments themselves, but we did want them to discuss the chemistry and to show the reactions. We also had them watch topic videos before they came to class and videos in class, and then they had a lab practical exam. And also behind the design of this, because this was new to the instructors, there were 3 instructors, and myself included, who were doing these labs. So I didn't want to put a big burden on the instructors who were teaching the class, and I didn't want to put a big burden on the students who were taking the class. So this is the list of the topics that we did. So we covered, you consider the traditional topics for organic chemistry, and it was a little bit challenging trying to find topics. So the ones that were highlighted in bold there, the solid liquid extraction and the SN2 reaction of alkyl halides, those were from the North Carolina State virtual reality. So you watch the video, you can actually click on the video, move things around, but if their computer system couldn't handle it, they broke it up into a series of YouTube videos. So students did all these experiments, and then at the end, they did a lab practical exam. And for the most part, I think it went pretty well. You had also students that this is their first experience with organic chemistry. So trying to get them to get it, a gist of it, but give them a quality lab experience, I think was accomplished. So now we'll hand this over to Dr. Ghebreyessus, and he's going to talk to you about remote teaching of general chemistry labs. It's all yours, Kesete.
Thank you, Dr. Waddell. Like Dr. Waddell says, my name is Kesete Ghebreyessus. I am a faculty with Dr. Waddell at Hampton University, and I will just talk to you briefly what we did in the general chemistry labs and briefly for advanced inorganic chemistry. What we did in the general chemistry labs, as you all know, we get students from all over the country, and some of them may not have enough chemistry, or some of them may not have seen any lab or any glassware. So because of that, we just thought that we can give them a little bit of feeling like as if they are doing these labs when they are in person. To do this, we first started with showing them the safety standards that should be followed in the lab, as well as showing some chemistry labs, how it looks like and what is in the lab. And then from there, we went on to describe some of the activities that we do. So this is, for example, the presentation that I made at the beginning of the lab session.
Sorry about that.
Just give me a few minutes to say. So you can see some of these are the design for the new lab module that we are going to have, but I'm showing them something is happening, Michelle.
Yeah, it's just jumping on its own. I'm not doing it.
You're not doing anything?
Yeah, go ahead.
Okay. So you can see the lab, me in the lab, with the coat and the goggles and show. Oh, it is acting out.
Yeah.
Is that the only page or?
Well, just keep on. We'll see.
Okay. So, I mean, that was, about the lab, as I believe maybe all of you in this conference today, maybe chems, so you know what is in a chems lab. So that's what we did in the first weeks and days of the lab. And then after that, we went on describe the safety protocols that should be followed while you are in a chemistry lab. Next slide, please. Next. Okay. Down arrow, Michelle.
Huh?
Press the down arrow.
Go next. Okay.
No, 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 not next. The
Oh,
down.
I got
Okay.
it.
All right. So what we did was, to describe what is meant to be safe in a laboratory environment. We just put some, a phrase or words and what they mean. For example, we explain what a hazard is, and then the potential that it can just be exposed to a danger or harm while being in the lab, and what can come up with from that hazard or damage. Next one. And then what a risk is, once we explain hazard, what is the risk, what are the potential source of the risk or the exposure that come from being in the lab, and how we can avoid that. Next. And then what cause lab accidents in general. And there have been studies, I think, in many different journals that show that about 15% of lab accidents come from maybe unsafe environment or condition, but the 85% comes from personal failure. So we discuss with the students, these are just giving you briefly the outline. Otherwise, we discuss a lot of the details in these different wordings or questions, like you see. And then we gave them, some of the hazards that can come from, personal, maybe fire, and then what you need to avoid those things. Next slide. And then, which I already said, the goggles, the, lab coats, if they are available, are essential to wear while you are in the lab, which I believe we already all do. Next. And then these are acronyms that are recently just given through the ACS. These are safety guidelines in the ACS undergraduate education, which is the RAMP, recognize, assess, and minimize. We in detail just describe what these acronyms are. And then we went on in detail with examples, some videos. There are YouTube videos that describe in detail these different acronyms and relate that to the specific safety protocols that we need to take to apply to these acronyms. And of course, these are again general. After we describe all the different entities in detail, we just summarize it in this, how to work safely in the lab, what you need to wear in the lab, what you not need to do in the lab, the cleanness, washing your hands before you leave the lab, and not eating in the lab, being aware of fire hazards that can come from dealing with chemicals that may be flammable, and so on and so forth. And then after this, you can say that it's okay, Michelle. Then after this, we gave them a lab test at the end of all this safety quiz, rather, safety quiz, so that we know that the students understood what did we discuss or what is meant to be safe in the lab. And it went very well, and they had some ideas about safety issues in the lab. And one of the things is, even though these are general chemistry students, some of the students are chemistry and biochemistry majors. So we thought that it is a good idea to expose them early on about the safety protocols, what the chemistry lab looks like, and what they expect from the lab. Once we do that, then we went on to the lab activities. And most of the activities that we did, we used the job videos, like Dr. Waddell was saying. This was, in the Hampton University's library website, and it was approved to be used with the educational service system. And we used that. And what we did was, instead of just upload the video on the Blackboard platform system that we use for teaching, what we did was we watched the video with the students, and the videos have background material and the experimental component. And once we watch the video, and then we break down the video, each part, explain to the students what is going on about each of the experiments. Then once we describe the videos and explain the content as well as what is it entails, then we prepare the simulated lab data so that they can write a lab report. The lab report was not as detailed as in the in-person lab reports that we do, but similar to what Dr. Waddell said with the organic lab, we generate some data, and using that data, they just wrote just very much close to what they were expected to write in the while they will be in person, and that went well as well. So for example, this is one of the simulates data for a lab activity or experiment number one that we did. This lab is about determination of densities of solids and liquids. And there was a video that described what density is and how to measure densities of different solids as well as solutions or liquids. And once they watch that, then we generate this. You can see they have to do certain calculations that is unfilled. And more specifically, at the bottom, you see they do standard deviations using the Excel software program. And then they do the other calculations on a paper. And then they have to discuss and describe their results well based on the video as well as this data. Next, please. And then, so that was for the general chemistry, and for the most part, it worked very well. And the students, comments and evaluations at the end of the semester were, encouraging, or they were well taken. So they were very good. The experience was good, even though it was not in person. And then I had another lab, which is an advanced in organic chemistry laboratory. For this lab, we did use job video as well, but for most of the labs, I have data that generated from my research lab, like you see here, and we use that data to give raw data to the students. Most of the data they were provided was UV data in the form of an Excel spreadsheet. And using that Excel spreadsheet UV data, they generated a UV beam spectra, and they explained the results, and they wrote lab reports as well. I will show you some examples of the substance that uh, we generated the data, and then the UV spectrum samples that they drew. And these are the solutions that they explain to the students how they make solutions for the UV analysis, which is showing them how the data was generated and then what they expect to see. Next, please. Yes, I saw a question. Are we supposed to answer questions, Michelle?
We're going to wait till the end of your talk, and then you can answer question.
Okay, then can you go back one slide?
I did. That's this right here.
This is this one.
Yeah.
So most of the work that we do in my lab looks like this type of chromophores or light sensitive molecular switches, and we generate a lot of data for this type of molecules. So it was good enough for us to use some part of this and exploit it to the advanced in organic chemistry. We do anyway, even in person. There is one of the, at least not only one, about two or three lab activities are related to the research that I do. And just it's very much as if they were doing this in person. The only drawback was they didn't do it by themselves. Go ahead, please. So these are the kind of substance that we make in my lab. And the data that I will show you briefly was generated, for example, for one of the ligands that are listed at the top. So you see, these are data that you can get them directly from the UV, but the student generated this type of data by using the UV's Excel spreadsheet that was generated from the instrument. Then it was sent to them, and that they use Excel to draw this type of graphs, and then they write the lab report, describe what the UV is uh, pertaining, or how it, in other words, explain what the UV is showing. I can go in detail, but I don't think that is appropriate at this time. But these are data that the students generated from the Excel spreadsheet. And thank you.
Okay, so for questions, we'll answer the questions all at the end to get everybody a chance to talk. So next we have Dr. Peter Njoki talking about his introductory chemistry labs for non-science majors.
So good evening, I'm Dr. Njoki. We're talking about the teaching of introduction chemistry for non-science major. Now this class is for students who are non-science major. These are pre-nursing students, kinesiology students, and continue. So in this slide, we have what we were doing pre-COVID. We'd have the students in the lab mixing chemicals, getting some good data, and also seeing some color change. Continue. But due to COVID, we found that we had to change a lot of things which we were doing. Go on. Now, just to give you a brief distribution of the students who I had in this class, there were students, about 60% were kinesiology major. We had 6% who were undecided, other just health science, pre-nursing, 16%, marketing, and psychology. Some of these students required the general introduction chemistry for their major. Go on. And most of the work which I'll be talking about, I published this work in this Journal of Chemical Education. Last year, the American Chemical Society had a publication whereby they wanted the faculty to give their experience or their reflection on how they were able to handle teaching of chemistry during COVID. So if you have a chance, you could go to this site and have a look at more details on what I'll be presenting. Go on. Now, there were quite a number of challenges which we encountered when we had to switch from face-to-face teaching to online teaching. We had just a few days to prepare. And one of the things which we realized was the availability of materials to use, cost, and relevance. Go on. And even when we overcame the cost and relevance, there was then the issue of students' devices, the software compatibility, and also broadband connectivity. Because for us to work online, the student had to have good internet, which could sustain some of the videos and also as we taught them during these times. Go on. And the other thing which was also a challenge was the lack of hands-on experience. We know that chemistry students need to do the hands-on work, but it wasn't possible during COVID. And also the other major thing was the lack of student-instructor interactions. Because when I teach the lab, I like to walk around interacting with students, showing them how to manipulate some of the equipment. But this one was not possible because of us not having the face-to-face teaching. Continue. And also assessment. So assessment, and I'll talk about it later, was also another challenge during this time of COVID. Go on. Now, continue still. Now, what happened is, as I was looking for materials which I could use, I came across this site, the Physics Education Technology, the PhET Interactive Simulation. And this simulation, they have materials for chemistry, physics, biology. And with this site, the student could manipulate data. And after they did that, we could pose some questions to them, and we could also have a discussion. Continue. So stay continue. So the PhET resources, as I said, is a free simulation resources developed by University of Colorado Boulder for teaching biology, chemistry, physics, math, and also earth science. For instance, when I was teaching the topic of covalent bonding or structure of compound, this was one of the activities which the student did. With this lab, the student could change the bonds, like going here, you can just cancel, remove a bond, or even add a triple bond, double bond. And as you did that, you find that you can get the geometry You could get the arrangement of electrons. You could even put electron pair, lone pairs. So the student actually did this simulation. And from this simulation, we had some questions which were posed to the student. And I also used this one not only in the lab, but also in class when I was teaching. Go on. Another thing was the topic of acid bases. So in this case, we had some solutions whereby the students could select a solution like a strong acid, see how it would conduct electricity. The other thing they could do, they could insert a pH paper and they'll see the color change. And the color change, they would also see a scale whereby if it changes to red, it is this pH and so on. At the same time, they could also use a probe, which when put in the chosen solution, it would give them the pH number. So these two were kind of hands-on, and the students were able to manipulate this and obtain good data. Is the echo coming from my side?
No, it's not you, somebody else. I'm trying to mute them.
I think it's the first.
Stefan, can you mute yourself, please?
Dr. Cooper. Okay, go ahead. So with this thing, once again, the student learned about the tetrahedral, trigonal, planar, and all the shapes by just manipulating the bond and angle. Then I also used the Njoki, the journal of visualized experiment like my colleagues. Here also, there were topical information one could use for chemistry, biology. So we went to this site and selected experiments which were relevant to what I was teaching, the non-science major. Go on. Now, Njoki resources are video-based peer-reviewed scientific journals you could publish on the journal. We had a subscription for these particular resources, which allowed us to embed the videos to Blackboard, whereby the student could have off-campus access. At the same time, the Njoki education gave instructors through I think Stefan.
Yeah, I can't.
Okay, yeah, he did. Okay, so at the same time, even though we have subscription for these particular resources, there are some areas or some sections which we did not have. But Njoki, what they did for all the institutions, they gave them free access until mid-June for the Njoki education video. So whatever we didn't even have access, we were able to access them, and we use them to manage what you are doing for this student during the COVID. Go continue. And I'm just going to show just two of some of the work which we did. One of them, like determination of the density of solid and liquid. The student would watch these videos. They'll see how you can determine. No, it will not play. Okay. So yeah, it will show you how you can determine the density of a solid on even a liquid. And after this, the students would have an exercise which they will perform. But just to mention, before they watch this video, we would have a discussion, something which I call the pre-lab exercise. I'll take them through. You start watching the videos. In case they had any question or any difficulties, I'll help them out. And then after the videos, there will be some post-lab questions. Go ahead. And the other thing which we did, which was almost similar to what Dr. Ghebreyessus had shown, they were able to determine the mass percent composition in aqueous solution. They did not actually do this, but what they did, they observed how you can go around doing this experiment. And later on, they had data which they were to analyze. And then there was a post-lab test to just evaluate them and see whether they had at least understood the concept. Continue. So once again, some of the activities I've mentioned, there was a pre-lab discussion on Zoom video. I use Zoom. The reason I use Zoom, with Zoom, it was possible to juggle from one window or one website to the other with the students. So the students watched the videos and completed the simulation activities. Post-lab tests were posted on Blackboard, such that the moment the students were done, they'll see their results. And afterward, we'll discuss some concept which maybe the student had not understood. And then at the end of the lab, just almost the last week, almost before the finals, the student had a final lab exam based on the videos they had watched and what we had accomplished during the semester. Continue. So in conclusion then, what did we learn? One of the things was all the stakeholders had to adapt to unfamiliar environment within a very short time. In fact, I think we had like 4 days to prepare before we could convert our lectures, our exam, and anything else to digital form so that it could be uploaded to Blackboard. It was a very daunting task for both faculties and students. So the learning curve was very steep, but we managed. Technology was a major issue, especially so with the broadband internet access. And we discovered this because some students, even when they were trying to watch videos, others, they'll tell you that, well, I cannot open these videos, I cannot do this. Hardware was also another issue for some students, and also software. Because there was some software, like if a video needed a student to use the Adobe Flash Player before it was discontinued, some students were not able to open some of the videos. But we work around on how they would be able to do so. So the other thing is the simulated or visual lab can be used as a teaching aid. Before, many faculty were not using this, but with what we've learned now, this lab or these virtual labs can also be used when you're teaching. You could just have the student watch, discuss a concept, because as we know, chemistry is very abstract. But if they can see some of these simulation or some of these videos, it helps them a lot. And also this could be useful like where there is resource limitation or some of the experiment which may be safety is a major concern. I think with that, I'm done with my section. I'm ready to answer question at the end. Thank you.
Thank you, Dr. Njoki. Now we're welcoming Dr. Edmund and Ndip, who's going to talk about teaching physical chemistry labs in a remote environment. The floor is yours, Dr. Ndip.
Okay. I am Edmund Ndip, and I teach physical chemistry. I believe we are all aware, having gone through the curriculum, particularly on the teaching side, what the difficulties are. One of the most difficult things about chemistry, and for that matter, physical chemistry, is its abstract nature. Okay, and sometimes, particularly in thermodynamics, okay, which is what we typically do, in the first semester, things that don't seem to be true actually are not true. Next slide, please. Just a reminder, okay, as to what the source of some of the difficulties are, and Michelle, just for the purpose of it, sometimes you may have to go 1 or 2 slides. Don't worry about me. I'll talk to that speed.
Okay.
But the problem here basically with physical chemistry, again, is that just a little reminder so that we appreciate its difficulty is the fact that it is mathematical, it is theoretical. Okay? So there is a certain requirement, or at least a mindset that both the instructor and the students have to come to it. And that's that we have to be open-minded, and we have to be prepared to do do a little bit of math. There's none of these areas of physical chemistry that will cut us any kind of slack, so to speak. So with again, some of the challenges. we've just talked about, and my colleagues have mentioned in a general sense what a lot of most of the difficulties are teaching chemistry during this period. Okay. Oftentimes by the time students get to physical chemistry, the connection between physical chemistry and general chemistry has been lost, because in our curriculum we slide organic chemistry between general chemistry and physical chemistry. So teaching physical chemistry at that juncture is almost equivalent to having to first teach the general chemistry and then worry about the physical chemistry. But nothing is impossible, so we figure out ways to get around them. So there's traditionally, if we're under normal circumstances, what would we do? We'll have lectures, okay, and then we go and do canned labs, okay, is what I refer to it as. But fortunately for me, over the years, I have been involved in simulation-based learning activities as far back as 2000. When I met my first association with NanoHub at Purdue University. Oh, that's wonderful. My colleagues have already mentioned the use of Jovi videos, and Dr. Njoki mentioned FED. Well, even at least a couple of years before COVID, we were already using FED to a certain extent, and I know there are a couple of people in the meeting at the moment, who've had that little experience with me before. But the real difficulty here was choosing activities that would actually help bring forth the physical chemistry concepts in a way that can actually be handled somewhat reasonably easy by the students. Okay, so had a difficult time choosing using Jovi videos. Okay. If you think about it, there is a lot of stuff out there for the beginning chemistries, to be honest. Okay, there is hardly there is very little to find at this juncture in terms of labs for that matter, for physical chemistry. Dr. Njoki mentioned software problems. Okay, there are a host of activities, okay, but most of those activities, simulation activities that is, require Java. And once that was either discontinued or not supported, okay, that limited the pool of activities. So most of what I chose to use came from FED out of the University of Colorado. The basic premise there from a teaching standpoint is that the students get to learn by doing. Okay, again, the students get to learn by doing. And so I chose a number of activities, okay, which from an instructional point of view, okay, the instructions, the students get the instructions in the same way that I do. And we execute the instructions. Okay. Basically, they generate their own data, and then they have to analyze and talk about that data from the context of concepts learned in lecture. Needless to say, for some of these, okay, I required one of two things. Either a worksheet is completed or a worksheet is completed, and then there is also the request for a standard lab report. And the standard lab reports that I asked for were in some respects along the lines of how we write journal articles, okay, requiring an abstract, an introduction, okay, and in the introduction, they will talk about the undergirding principles. Okay, and then there is a procedure, Okay, and that procedure invariably, also it would require, the mention of instrumentation, if any, is used. They present their data and results, and then talk about, discuss, the activity and its totality, and whatever calculations were involved. Okay, that was the lab report. I have here, a listing, of some of the activities, that we covered. In one particular one, a couple of them, in particular, okay, using the ideal gas law, there was a particular activity, where they used, the Dumas method to determine the molar mass of some unknown liquid, okay, based on the ideal gas, equation. Okay, as one activity, okay, from, I believe that one was from Njoki. Okay. The rest of the activities were from using the FED side, and we've got a couple of them here. Next slide. Not sure if there's plenty of wording here, so that I don't leave out anybody's work that I used. Okay, but this is a much more detailed description of what was in a couple of the activities that we did. As I mentioned, here, Njoki, we did a couple of things from Njoki, and then the other things were in general. I looked around also for YouTube videos. Okay. There were there's some experiments that we typically do, and for some of those experiments, there is plenty of information in the literature already as to how to execute them, i.e. the one about the spectrophotometric determination of an equilibrium constant. Okay, that was a combination of the Njoki video and YouTube instructions we got from the net. Of course, these are standard experiments that are usually done. So the Njoki video and the instructions from YouTube were simply to get an idea of if they were actually carrying out this experiment in the lab, what will they do? And then I got data from the literature, okay, actual data that is, which the students analyzed and wrote a lab report correspondingly. Okay, yes, I did. I sure did. Took a couple of things from there, from CHE, GG, Greg. I think they are a paid service, for homework and other things. So they were, so that was the case, for the spectrophotometric determination, and the other experiment, that we used, actual data, from the literature was the determination of molar mass, okay, based on freezing point depression. Essentially, what were the lessons learned? Given the difficulty for physical chemistry, I think that particularly during these times, it is possible for students to actually, when they get to do these things themselves, in my opinion, I think that's empowering because of the math requirements in physical chemistry. Actually, this approach in terms of using simulations, okay, actually gives students an opportunity to get around concepts, okay, with minimal math training.
Okay, thank you so much, Dr. Ndip. And I'm going to open up the chat to see the questions that were put in here earlier so we can get to some questions. Okay, so one question for any one of our speakers is, how do you choose which experiments to convert? Was it that you followed the curriculum, or did you completely pivot and find new content to fit the virtual model?
If I may speak, since I was the first, in general chemistry, it was a combination of both. Some were just following the curriculum because the job video that you saw from each of us, from Dr. Njoki as well as Dr. Ndip, it has uh, quite a bit of similar kind of lab activities that we do when students are in person in the lab. But there were a few experiments that we modify and find out similar activities and generated a new lab activity for the students.
I concur with Dr. Ghebreyessus. That's what we did. And for like the chemistry I taught, the students don't require much of the lab. So the content which I used was what I had on the syllabus. And some of the labs is what we'd have done in person. But we just tried to take advantage of what was out there to suit the situation.
Okay, I have another question. I see you made use of CHEG. Did you find your students also using CHEG, minimizing their learning? If so, how did you minimize this?
I suppose I used CHEG. The way I minimized this is that I selected activities for which there were no solutions posted, and as a matter of fact, there were a number of different times where I actually worked with them in terms of analyzing the data as opposed to them going and trying to find out what the answers are. They know that I spend a lot of time looking around looking for things also. So I could very easily tell based on the comments that I was getting that they had trying to find they tried to find answers to the questions that were being asked, and they couldn't, so they had to come back to me.
Okay, had a question about using virtual labs for general chemistry. Were there any uses of virtual labs for the general chemistry labs? And for the raw data, do you have students work in groups, or did each student get individual data sets?
Number one, the video sets that the students were watching were very, very similar or the same. And after they watched the simulated videos, what we did was we generated a set of data, I believe about 6 or 7, and then we grouped them in groupings. So they were working as partners when they write the data. But even if they share the data, the students were writing the lab reports individually so that they can learn themselves how to discuss their results and then explain what they observed in the simulation videos. But yes, they were sharing data in groups.
Okay, thank you, presenters. We're not done. We have our students online. So Maurice Johnson is a senior, graduating senior, and he is the president of the Hampton University chapter in NOBCChE. Trinity Neal is a junior, and Amani Porter is a sophomore. So I'm gonna stop sharing my screen so you can see their lovely faces. So guys, can you unmute yourselves? Maurice, Amani, and Trinity?
Yes.
Okay. So first question is, how was your experience doing online labs?
I guess I can go first. My experience doing online labs for last semester, I'm in organic chemistry right now. I actually didn't find it that bad because I wasn't exactly sure how they were going to do it, because I knew how it was done in general chemistry, where we were always mixing something together. So I was like, okay, how are they going to do it online? Are they just going to be like, well, if you put this and this together, this is what would happen? So I didn't know how it was going to go, but I kind of liked how we did it because I should have remembered what program we used, but there was a simulation where you could pretty much build a molecule, and we were doing orientation of the molecule at that point. We were talking about steric hindrance. And so I thought
you're in the honors section organic.
Correct? Oh yes, I'm in the honors section of organic chemistry. And so we had to figure out the steric hindrance and the amount of potential energy that that molecule had based off of the angle of it, what the angle of the rotation was. And so I thought it was really helpful because I know you could do it live and maybe with the actual model, but I thought it was really neat because you could have the program show you different settings and what the molecule was in. And I thought it was really useful. So I thought it turned out better than I thought it would have.
Okay, Trinity?
I definitely liked it a lot more than I thought I would. When we first got moved to online classes during COVID, I've had teachers just give us the data, no video. It was just like, okay, write the lab report. And that was definitely for physics, so it was hard. But I do like the whole format using Jove and PHET because it makes it a lot easier to understand. And I feel like it makes the concepts like more visually sound. Like I was in Dr. Edmund's physical chemistry class, so you were seeing the ones with like the gas particles and stuff like that. And if you literally put too many in there and increase the pressure, it would explode the container lid. So that's like easier and for me to see visually because I'm more of a visual person. So I really do like them better.
Okay, Maurice?
I also enjoyed the virtual labs, but I think my level of enjoyment really came down to which service I was using. I wrote down some of the ones that I've been using in the last year: Lab Exchange, Beyond Labs, Value, which was the virtual Amrita Laboratories universalizing education system, and then Labster. Um, they all had their pros and cons, but what I enjoyed the most was when I had some amount range of like free reign. So like if you put me at a virtual lab bench and I was able to pick what I wanted to do, I really enjoyed that because it really simulates what a real lab would be like. You can make mistakes. You could grab the wrong chemical or use the wrong piece of machinery. So that's really important. One thing I did have trouble with though was sometimes you'd run into little technical issues where you wouldn't realize that when you pick something up in a simulation, you've got to double click to get it to dispense, like little things like that. So like this ease of use would make virtual labs a little bit more, I guess, difficult, and things I didn't. It made it unenjoyable sometimes, but certain ones like Labster, that was for a biology lab. I think they have chemistry labs available, but they cost some a bit of money to do them. But I think that was the best system that I used, simply because it was a guided direction. It also prompted you with questions to help you learn and master the concepts. And if you did make mistakes, you were able to go back and redo them.
Okay. Another question for all you guys is, were you able to interact with other students in your class when you moved from in-person to online?
I would say yes. I don't know about other schools, but we have like a small like kind of cohort for the chemistry majors. So we all knew each other like going in. So we already was able to like make group chats and things like that. But if there was a case where we didn't have someone's contact information, like during class, someone would like make a group chat link for GroupMe and drop it in, and we'll be able to contact each other. We would schedule like Zoom meetings so we could study for tests and work on homework together and try to better help each other comprehend the material.
Okay. Amani or Maurice, you want to add to it?
Yeah, so I had someone I worked with during general chemistry and then last semester with organic chemistry and again this semester. So we've been working together as just a duo when we need help with the homework. We're like, oh, we'll just schedule a meeting to work on things together. And it helps to have somebody to one, hold you accountable to make sure you're on top of everything, but also just bounce off ideas and be like, oh, he was talking about this in class, maybe we should do this. So it helps with just explaining and learning while during virtual setting.
Okay, I wanted to also agree with what Trinity was saying. My group of friends, the seniors of the chemistry department, we all have our own group chat. I do like what Trinity was saying about having Zoom meetings for studying for tests. We didn't do any of that, and it made it really, really difficult. Like I'd forget dates for assignments, and what probably would not have if I had been regularly talking to people. So that's definitely a good idea.
Okay, Maurice, Ashley asked if the different online system you're using, can you put it in the chat for people? The one
Yes, sure.
Ma'am. Okay.
Oh, I said sure, not sir.
Oh, okay. So that is all I had. So Maurice is gonna put those online instruments that he talked about. I know Beyond Labs was one of them. And does anybody have any other questions?
There was a question, Michelle. Can you check the chat? There was a new question.
Oh, there was a new question? Okay. Okay. What role does tutors play on the students when taking an online lab? Can you guys answer that?
Do we have tutors? I don't think we have tutors. What tutors? I don't know. Do you have inorganic?
Well, like the student support services. I mean, we had tutors for lecture.
Then you guys organic. I had no experience with any tutors in general chemistry.
Well, I was
during
saying,
the COVID time.
why I say for organic, because organic, I mean, they had general chemistry outside, like they can go to outside tutor online. But as far as organic, I actually had the tutor attend my lectures. I did it in Top Hat, and she attended my lectures, and she actually attended the lab as well, so she knew what was going on. And if they put something in the chat and I might have missed it, she would answer the question, you know, if it was a basic question, or she would alert me to it. She also attended the lab, so we got her admitted so that if something come up, they can ask her questions based on, you know, how I set it up and how, and you know, how the whole over thing. And she had outside tutor session that they can go and attend. And if the students couldn't make it, she would send me the video, and I would post the video of the tutor session on my Blackboard page. Okay, so I think that's it. Thank you so much for attending. Really appreciate it. I think we got a good group here.
Dr. Cooper, are you there?
And just to remind everybody, I do believe this is being recorded. So the recording will be on the NOBCChE National Conference website if you want to, you know, go back and look at it. So everybody have a good evening. I know it's 7 o'clock. End it on time.
All right.
Okay. I'm sorry. What was I saying?
Will the slides be available?
I can talk to the NOBCChE people. I can email it to them. So yeah, I have no problem.
Thanks.
You're welcome. So everybody have a good evening.
All right. All right.
Bye.
Thank
you
Bye-bye.
guys again.
Thank you. Bye.